Okay, we're going to talk about section 2.5. 2.5 deals with using the linear models. In the previous sections, we've dealt with linear models with writing them 2 points and so on. Now we're going to look at correlations, a little bit more statistics theory here as we go through. Graphs of data pairs for real-world situations rarely fall in a line. If they fall in an exact line, it's very unusual. Their arrangement, however, can suggest a relationship they can model with a linear function. In other words, they look like a line, but it isn't exact. Essential understanding. Sometimes it is possible to model data from a real-world situation with a linear equation. You can then use that equation to draw conclusions about the situation. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. You use a scatter plot to determine the strength of the relationship or the correlation. The strength of the relationship is the correlation. Two words that go hand in hand together between the data sets. The closer the data points fall along a line. And I didn't finish that sentence. The closer the data points fall along a line, the better the correlation it is. And the stronger the positive and negative correlation between the two variables. Now let's look at a few examples here. We have a strong negative correlation. It goes downward. Strong because the points are close together according to a line and it's going downward. This is a weak negative correlation. They still go downward, but the points are more spread out. This is no correlation. Neither go up nor down. This is a weak positive, going up to the right, but the points are spread out. This is a strong positive. They go up to the right and they're more closely together. So we have, now when we look at this, and this doesn't really talk about it in the book this way, if they go up to the right like this, where there's a strong positive correlation, the R value, you'll see in the calculator later on, will be close to 1. Where there's no correlation, the R value is going to be close to 0. And when it's go down like this, the R value is going to be close to 1 again. It's a good correlation. And we look at it, when it gets close to a line, it's going to have a nice R value. Now let's look at a problem here. I'm going to extend this down a little bit. Okay, use the table as an average temperature and electricity costs Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? So I'm going to make it out a little bit further here, and I'm not very good at making lines on here. Actually, I'm going to go back and redraw that. Okay, let me see if I can get a straight line here. Right there. We're going to go that way. Okay, here's my scatter plot. Now I'm going to look at my average temperature and electricity bill. Okay, so I'm going to put bill on this side, temperature on this side. And you notice I'm labeling everything. You have to make sure you label everything. Now look like the temperature goes 61, 58. 58's the lowest. Yep, and goes up to about 85. So I'm going to go 50 right here. Might want to throw a broken axis in here. Then we go 55, 60, 65, 70, 75, 80, 85. Okay. Now the electricity bill goes 139, 110. Anything lower than that? Nope. And it goes up to 210. It looks like, or 234 actually. So 110, and I'm going to put a broken axis that way. 120, 130, 140. 50, I'm going to mark that one. 60, 70, 80, 90, 200, 210, 220, 230, 240. Okay, now I'm going to plot the points. So the first one is at 61, which 61 and 150. Plotting a scatter plot, you're just going to put points there. 58 and 139, so it's a little less. Down here, 67 and 172, 67, 172, and I'm estimating a little bit here. 75 and 205. Let's see, 60, 75, 205, 79 and 170, 83 and 234, 84 and 255. I must have missed that one. I'm a little bit higher yet. 85 and 245, 81 and 210, 76 and 183, 65 and 132, 65 and 132, and 58 and 110. Now the points aren't the nicest points in the world here, but they kind of give you the point of what we're looking at. And it says, how would you make your conclusion? Well, I can look like this. This is a positive correlation. It's going up to the right. And actually, I think it's a pretty strong positive correlation. The more temperature goes, the more electricity bill goes up. Temperature drops, or temperature increases, electricity bill goes up. So this is a strong positive correlation. Now here's another one. It says the table shows the number of hours students spent online the day before a test and the test scores on the test. Make a scatter plot. How would you describe the correlation? Okay, so what's this go here? There's not a lot of values here. I'm going to make my lines again. Okay, and then my points, it looks like I went to 0 to 1, 2, 5, so excuse me, 3, 4, 5, and they went from 57 to 60, so I'm going to have a broken axis. I'm going to go 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So at 0 hours of studying, I'm going to put 0 right here. 0 hours, they get 100. So I'm going to put a dot there. At 0 hours, I get a 94. At 1 hour, they get a 98. At 1 hour, they get an 88. 1.5 hours, they got a 92. 1.3475, they got an 89. 2 hours, they get a 75. 2 hours, they got a 70. 3 hours, they got a 78. 4 hours, they get a 72. In 5 hours, they get a 60. So how would you describe the correlation? Now this correlation, it's fairly strong too, but it's a negative correlation. It's going down to the right as you go through. Now it says here, part B, reasoning. Use the graph from problem 1. How much would you expect to pay for electricity if the average temperature was 70? So if I go back to my graph, I'm just going to go back to this page here. If it was 70 degrees, 160, 65, 70, and I go up, my line would be somewhere in here, and I go over probably about 70 degrees, I'm going to be paying, and what I'm going to do is make a line up. I'm going to draw my line in here. Probably my line of best fit, and we'll talk about that in a second, is going to go right to the middle of the points. Now if I go over to 70, 65, 60, 65, 70, drew a line up to the line, then drew a line over to here, it looks like I'll be paying about $190 for the bill. That's how how you read it. Might be a little bit more, might be a little bit less, maybe $93 or something along that line. Now a trend line is a line that approximates the relationship between the variables or data sets or of a scatter plot. You can use a trend line to make predictions from the data. In the previous lesson, you learned how to use 2 points to write an equation of a line to model a real-world problem. You can use this model to write an equation of a trend line. So on here it says you have table shows the median home prices in California. What is the equation for a trend line that models the relationship between the time and home prices? So I'm going to go on here, draw my line in. We're going to go 1940. I'm going to go 1940, 50, 60, 70, 80, 90, 2000, and then I don't know how far we're going to go up here. Let's go by 30,000. 60, 90, 120, 150, 180, 210, 240. That should be pretty good. So my first one is 1940, 36.7, which should be a point right about there. Next one would be 1950, 57, a little bit higher. Might be off a little bit. 74 would be right about there. Might be a little high on these. 88. Then it jumps at 1980. It jumps up to 160, 30, 60, 90, 120, 150. Then up to 249, which is way above here. Then it goes to 211, right about there. So there's my scatter plot. Now if I wanted to find a trend line, like I said, you want to take a line that matches up pretty good with the points. So I probably would go, let's see, what point would I want to use? Is that a good trend line? That one. This one's a little bit out of range because it's so far away. Now this one's not too bad trend line. So what I'm going to do here, because I got a couple points below and a couple points above, I'm going to use this point and this point to do my equation. So the 2 points I'm going to use are right here and the one at 1960 right here. Now notice on here I put my price over here, year down here. So my year is my X, my price is my Y. So if I'm going to do my line, I'm going to have to change my slope first. So my slope is change of Y over change of X. So 211 500 minus 74 400 divided by the years, 2000 would be 40 years. So if I subtract that, and I don't know what we get to get, I'm going to pull my calculator out here to get this one. Give me a second, because we're going to use the calculator on the next problem anyhow, so we need it out for future problems. Okay, so here's my calculator, I think. Still thinking. Okay, we're going to go, I'm just going to do a little math first time here. Move it over. It was what? 211 500 minus 74. So 211 500 minus 74 400. Enter, divided by 40, enter. I'm going to go up and get the right answer here. Enter, control, enter. So my slope is 34,027.50. 34,027.5. So now if I want to find my point, I'm going to use one of the points I just had here. And so to write the equation, y minus 74,400, the y coordinate, equals 3427.50 x minus my year, 1960, and that's going to give me the equation of the line that best fits that data. So it kind of, and you can solve it down from there as you go. Now let's try another one here, and I'm just going to look here. This is the last problem I'm going to do. The trend line that gives the most accurate model of related data is the line of best fit. One method for finding line of best fit is called linear regression. You can use linear regression function on your graphing calculator to find a line of best fit. The correlation coefficient R indicates the strength of the correlation. The closer to 1 or a negative 1, the more closely the data resembles a line as you go through. And I want to talk about that a little bit here as we go, because I want to go back on the one problem. You know, when I started this video, we talked about the value being closer to 1. It's a good relationship, and that's the same setup here. But I said it says if it's in the negative correlation, then it's closer to a negative 1, and I put positive 1. That was my fault there as I go through. So we're going to do this problem on the calculator. So we're going to pull our calculator up and enter the values. We're going to have these as my x, and these as my y. Okay, so let's pull the calculator up again real quick here, and we're going to go home, table and list and spreadsheet. We're going to label our first list x, second list y, and you can put in there year or an average cost. It doesn't matter. So in our first list, we're going to enter our years. So we're going to have 1998, 2000. This is from the list now. 2000, 2004, 2006, 2008. Now from the second list, we're going to put the y values. And now the y values are 2.57, 2.83, 2.93, 2.93, 3.10, and 3.71. Now to find the linear regression, we're going to go under Menu, Statistics, Calculations, Linear Regression. Now there's two of them. We're going to make sure we pick the first one. We labeled our first list X, our second list Y. Column reference is C, and we're going to click OK. Notice that we get an equation now. Now our equation says here, this is the equation we used to have in y equals mx plus b. Y equals mx plus b. My m is 0.093, which is my slope. My y-intercept is a negative 183.267. And my r value is 0.906. You notice the 906 is a very strong positive correlation. It's positive because it's positive, and it's closer to 1. So now if I wrote my equation out, I must remember 0.093. So I have to remember this now. I'm going to go over here. So my equation is y equals 0.093x plus, and I have to go back to the calculator real quick, a negative 183.3. Okay, now it says based on your linear model, how much would you expect to pay for a gallon of 2% milk in 225? And this is the one I want you to do. When you have your equation, what you want to do to find an expected value is just to plug that value in to your equation. Now 2025 represents the year, so you're going to plug that in for X, and you're going to solve for Y, and I want you to hand that in. Long video for some easier concepts, but I want you to make sure you understand this as you go. Have a good night.